What is a triangle? Triangle is a three sides, a covered area of three sides, three straight lines. And the major property or the axioms, I mean, axiom, what do you mean by axiom? Axioms are something which you don't need to prove. You know? The Hindi word for axioms are avigrihit. So it says that all the angles of a triangle A, B, C should be 180 degree. Now all the angles of the triangle should be 180 degree. So when there are two triangles whose angles are same, A, B, C, P, Q, R. If there are two triangles whose angles are same, here you have to write like angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. If this is the case, then we write that triangle ABC is similar to triangle PQR. And you need to remember that we have written in a manner so that all the angles should be respective in respective order. Okay. So either I'll write this or I will write BAC, triangle BAC is similar to QPR. So if you will follow this representation, at least you will get to know that which angles are equal in the triangle. So how do you prove similarity of a triangle? So the one way to prove is if two angles are same, both the triangles must be similar. Why? Because if let's say if there is a triangle ABC and there is another triangle PQR and angle A is equal to angle P or angle P is equal to angle Q. So automatically the third angle in both cases will be 180 minus A plus B or here 180 plus 180 minus P plus Q. So it will be subsequently the third angle will also be equal. So angle C must be equal to angle R. Other situation which you can encounter sometime where they will write something like this. Now, there is a triangle ABC. There is a triangle PQR. PQR, and they will say that this side is 4 and this side is 6. This side is 5 and this is 7.5. So what you see here is the respective and also angle C is equal to angle R. So what you are saying here is that there are two sides which are in equal proportion, and 2 is to 3. This is the proportion of these two sides. Here also you are getting 2 is to 3, and the angle between those two sides is same. So in this case also, these two triangles are similar. And you can revisualize it by taking the same angle at one place, and if we'll go in the same proportion, sorry, in the same proportion, of course, of same proportion of the sides, we will always get a parallel line. So in all these cases, these all angle will be same and these all angle will be same. So all the triangles which are being created here will be similar to each other. Each other. So what did we see? That if any two triangle is similar, their angles will be same, and the property that we derive through similarity is that their sides will be in same ratio. Respective sides will be in same ratio. So the first of all, you will always mark the angle, all the equal number with if there is no alphabetical order is given, I will just write 1, 2, 3, and here I'll write 1, 2, 3. So and let me write also A, B, C, and P, Q, R. So what we can see that the angle 1 has in every triangle, angle 1 lies in front of a side. So uh, the ratio between BC and QR will be same as ratio of AC is to PR will be same as ratio of AB is to PQ. And this ratio, we call it the ratio of similarity. I call it ratio of similarity. You may find another word if Brooks has, but we will find a great help from this particular term. So this is called ratio of similarity because all the angles are same. So the sides automatically will expand respectively in the same ratio. So in other way, we can just write, if we take any pair of sides in any uh, pair of sides in any triangle, like in the smaller triangle from triangle ABC, I'm taking the side in front of angle 1, which is BC, and I'm taking a side of angle 3 in side in front of angle 3, which is AC. So this divided by this will always be equal to corresponding sides, ratio of corresponding sides of the other triangle. So here also in PQR, we need to find side in front of angle 1. So angle 1 is here. So the side in front of is QR, and side in front of 3 is PR. So this is how we identify the ratio and corresponding ratio for one ratio. So in any question, if you are finding two similar triangles, just try to mark the angles so that it will make your entire calculation easy. Okay. So these are the property, and this is the property that we will be using or finding very helpful in solving questions. Other thing is that if two triangles are similar triangle, all the measures which involve sides or summation of sides or which has a unit of single power Like let me make you understand it by example. So there is a triangle ABC and there is a triangle PQR. And of course, these two are similar triangles ABC and PQR. And let the similarity ratio is 2:3. So I have already explained you what is the similarity ratio. So if the similarity ratio is 2:3, all the sides or side-based calculations will be in 2:3 ratio also only. Like perimeter of triangle ABC ratio is to perimeter of triangle PQR. This will also be 2:3 because if the sides are in ratio 2:3, the summation of sides will also be in 2:3 ratio. If we are taking a height in this triangle, which is being drawn from angle 1 to the side, so if we are taking AH height and the corresponding height here is P, let's say PS. So if we're taking the corresponding height, it will always be in the same ratio as the ratio of similarity. Like AH ratio PS will always be 2:3. And similarly, all other heights. But if we'll try to see the area, like for this triangle, the area is half into, and I have already given you the given you what height. So you can easily calculate the area of this triangle is half into BC into AH. Half into BC into AH. And in triangle PQR, it will be same as half into QR into PS. So now if I know that this is in 2:3, this is also is in 2:3. So I can just let's say that this triangle has like 2B into 2H. So it will be the same ratio as 3B into 3H. I have taken the ratio. So what we are getting here? The ratio of area as 4:9. So the area which we are getting has the ratio which is a square of the similarity ratio. So if ratio of similarity between two triangles is 3:4, then ratio of their areas will be what? Then ratio of area of triangles will be 9:16. Okay. So this is how we get the we got the ratio of their area. Now, one of the major application of similar triangle is not major application, but one of the chapters that which also comes with similar triangle is uh, midpoint theorem. And this is very interesting because you may find one of the questions in your papers from this topic only. So midpoint theorem says that if there is a triangle A, B, C, or you may name it anything. So midpoint theorem has two kind of statement. You can tell it in both ways. First kind is if midpoint of two sides of a triangle is connected, it will be half and parallel to third side. So this means that if we'll connect the midpoint of AB and AC, and if we'll connect these two, the point DE, the line DE will be half of BC. DE will be half of BC, and also DE will be parallel to BC. Okay. So, and the second way to represent the same is if we start drawing a line from a midpoint of a side parallel to another side, parallel to another side. So what we are doing, if we are starting from, like in this case, if this is the triangle ABC, and I'm starting from midpoint of AB and trying to draw a line which is parallel to BC towards the third line, it will always divide the third line at midpoint. It will always divide the third line at midpoint. I hope you are getting those two statements are ultimately the same. Both are saying that this particular line, you know, how it acts, like if it is a midpoint of two lines, it will be uh, half and parallel to the third line. And here, if we're starting a line from a midpoint line parallel to the third line, uh, it will divide the third line at midpoint, and again, this particular line will be half of BC. So this is how we write midpoint, and the generalization of midpoint says will be coming to the proof part also. The generalization of midpoint says that it will be true for all ratios. True for all ratios. So that means if we'll rather than taking the midpoints, if we'll take a point which is 2:3 of both of the lines, then it will be 2/3 of the third line and it will be parallel again. So this is how, like, I'll not speak the entire line here because you will get confused. Let's go back to the proof part, that how it is happening. So let's take the first statement and we'll prove, and then we'll also take the second statement and then we'll prove that also. First statement said that you connected the two midpoints. So in a triangle ABC, if we are connecting the two midpoints, so what you can see here is you have two triangles. One is triangle 1 is triangle ABC, and triangle 2 is triangle ADE. And what do you see here is ratio of AD is to AB in both triangle. AD is to AB. It is 1:2 for the two triangles. Then angle A is same for both the triangle. And the ratio of AE is to AC. This is again 1:2. So what did I say? The ratio of two sides, side 1 and side 2, or angle between them is same. So this ratio is same for both the triangles. So with this, we can conclude that triangle ABC or ABC is similar to triangle ADE. So if it is similar, this particular angle is same for both. This will be equal. And if these two angles are equal, so it is basically the case of parallel lines. So you can just say that DE is parallel to BC. So one part is over. Now, can you tell me what will be the similarity ratio? Similarity ratio is any particular side ratio. So AD is to AB or AB is to AD. Yeah, and the triangles is ABC. So this is 2:1. The similarity ratio is 2:1. So DE will be half of BC. Okay. So this is the proof for the first statement. Now, if we'll go for the second statement, which says that if we'll start from midpoint of a triangle parallel to any line and go to the third side. So if it is parallel, this is midpoint of 1:1. If it is parallel, then this angle is 1, then this is 1 also. And this also will be equal. So we have two triangles, triangle ADE, triangle ADE, and triangle ABC, where all the angles A is common for both. Angle D is angle to B, or angle E is equal to angle C. So since all these three angles are same, so these two triangles will be similar to each other. Okay. Now, if it is similar, then it will have a similarity ratio. So here, what we can see here is 1:1. And what one mistake that everybody does, what they write is the similarity ratio as 1:1. No, this part is 1 and this entire part is 2. So the similarity ratio is 1:2. Okay. and when the both of the triangles are similar, this will also follow the same ratio. 1:2, and consequently 1:1. So now if we have proved the statement here. So now what I was telling you, that this particular thing will hold true for all the triangles. So let's say if we have a triangle and it says that there is a parallel line which divides these two lines in the ratio 3:5, A, B, C. Just a second. Okay. So the question is, if this side, the length of this side is 20 centimeter, what will be the side of DE? Or the next question would be, what will be the ratio of area of ADE is to area of triangle ABC? So in both cases, one thing that you need to know is that uh, if DE is parallel to, the given point was DE was parallel to BC. Na? DE is parallel to BC. So we know that it must have divided the line AC into the same ratio. So now we know that these two triangles, the smaller and the bigger triangle, will be a similar triangles. So what will be the ratio of similarity? This is the biggest question here. Can anyone tell me what will be the ratio of similarity? बताओ, बोलो, बोलना है किसी को. What will be the ratio of similarity of the
3
two
is to 8.
triangles? What?
3 is to 8.
Yes. Never say 3:5. You just need to remember that this part is 3 and this part is 5. Of course, in ratio terms. So if you want to find the ratio of AD is to AB, it will be 3:8. And any side's ratio is the ratio of similarity, 3:8. So if BC is 20, then D will be 3/8 of 20, which is 7.5. I hope you all are getting it. 7.5. And the ratio of their area would be 9:64. Okay. So this is all about the similar triangles. I don't think like you will need extra theory. You just have to use this concept in problem solving. So I'll find the lecture, previously recorded or done lecture. I'll give you the recording of that, and and we'll have 3 more classes in geometry. And let's try to finish the entire exercise of geometry this week only. Like the week that has started or will start from tomorrow. Okay. So till next weekend, we'll cover everything from geometry for CAT. Okay. And anybody who's preparing for CUT, they don't have to do all the exercise. They just need to do exercise which is in the book. Okay.